Hello, so I'm Mary. I'm from EDF Research Labs, and I will present a joint work with some people that are there and that can help me for answering questions after the talk. Bonjour. And I will present experiments we have made on Hadoop and a proof of concept for storing and managing a large number of time series. So the presentation will be as follows. I will give you some context elements briefly about Électricité de France, EDF, and about the data we focus on. And then I will present the POC using Hadoop. So EDF means Électricité de France. It's a group which is an electrical company, an integrated utility, and that covers all business, all aspects of business for energy, regulated business like transmission or distribution, or not regulated like supply, trading or generation. EDF has a strong footprint in Europe, with a total of nearly 40 million of customers worldwide. It has different affiliates and subsidiaries in Europe mainly, and also all over the world. And is the historical energy and electrical company in France, but after the market deregulation, it has also it has come to the gas market in Europe. So for utilities, smart grid projects represent a big challenge, and there are smart grid projects are launched all over the world. So here you've got a map provided by Google where you see all these projects launched mainly in Europe and North America. So for EDF, it's also something that is important for us. In France, there is a recent law that implies the future deployment of smart meters for all of our customers. So that means that within a few years, there will be 35 million of smart meters that will give data to our company. So at the moment, there is a pilot project that has been run, and 300,000 meters are deployed in 2 different areas in France. And of course, EDF is involved into this project. It's called the Linky project, and it's involved through its subsidiary, which is the distributor, which is the ERDF. EDF is also implied in different regional demonstrators in France, whose objective is to show the feasibility or the value of different smart grid issues. For example, the integration of photovoltaic generation or things like that. Smart grid is a word that is very often used. In fact, smart grid projects are launched due to different constraints or pressure, economical pressure, social and policy constraints, as well as environmental ones. The main objective is to be able to deal with distributed generation, new usages like the electrical vehicle, and also to be able to offer different demand response actions which are efficient. But finally, smart grids mean at first the deployment of smart meters and the deployment of an IT infrastructure that will be above the old electrical network. So it represents a quite big challenge for the utilities. I will then focus on the kind of data we chose to process. I call them the precious load curves, some kind of holy load curves, because they represent a lot of information for our company. So I will give you some examples of how they look like. I will show you different levels of aggregations of these curves. Here you've got 3 annual cycles of the French consumption. So you see that there is a kind of cycle. It's the consumption is very high in winter and lower in summer, because in France what is more important is the heating more than the cooling. And the second curve is the 1-year curve. So you see that it's quite regular with this consumption very high in winter. There is a kind of weekly cycle. And there are also different special events or special days that often give perturbations to this curve, like Christmas, May, which is the period in France where there are different out-of-office days, so the consumption is very irregular, and August, where everyone is out of the office. Here you've got weekly curves, and you can see the difference between 2 curves, one when the temperature is high and one when the temperature is low, to see the influence of the weather. And you can see in this curve there is also a cycle and a peak. It's at 7 p.m. The peak in France is at 7 p.m. when people come back at home and when there are still offices open, and at 7 when people put back their heating. And finally, here are some examples of individual curves, and you see that they are very, very chaotic. And even for a same customer, on the left you've got for the same customer 2 different curves corresponding to 2 different days. And up you've got for the same customers, for the same day, 2 different customers. So these curves are very irregular, but you can have a lot of information with them. It is important to notice that for the moment we don't have all this information for all the customers, because the smart meters are not deployed yet. So what we have for all of our customers is 2 measurements a year. And that's what we manage in our information system. We manage for billing, we estimate measurement every 2 months. So we've got 6 information a year for 1 customer. And in the future, we will have an information every 10 minutes. So it's a big gap for our information system. That's why we focus on this data, and that's why it's important for us to see which techniques and which methods can allow us to manage this data. We're part of the research division, and the objective of this research division is to anticipate these issues. That's why this work has been done there. And I'm sure you have understood that for the utilities, finally, this big data wave is a reality. And we do think that our core business will involve more IT and more data management than in the past, because of this, all this data coming into the system, because the system is more and more complex. So our project, which is called Sigma, deals with scalability and big data issues, and he studies different methods for storage and also for data processing. We have studied different things on complex event processing, for example, for making consumption forecasts, online for consumption forecasts. So we do online machine learning, for example, and also large-scale data mining, and the use cases deal with all the business applications. So now I will focus on our experiments using Hadoop. our objectives was to make a proof of concept for running a large number of queries with variable levels of complexity and variable scopes, variable frequencies, and variable acceptable latencies on all this data. And on this data we consider that we have for each of our customers one measurement every 10 minutes, and that we store it for 1 year. We linked with this data, this measurement data, with weather data, contractual information, or information of the network, of the electrical network. So the annual volume that we have to deal with is more than 100 terabytes. It's not so big. Maybe you think it's not so big because you may deal with larger amounts of data. But for us, it's quite important, and we think it is an important volume regarding all the processes we want to run on the system, on one and only one system. In other words, we want to build what we call an operational data warehouse, able to supply this large volume of data while ingesting, always ingesting new data coming from the meters. And we want the data coming from the meters will probably have a poor quality sometimes, so we want to pre-process it, to synchronize timestamps, to impute data when data is missing. So when uploading the data, we have to do all this pre-process. And we want to run different queries, simultaneous queries that are very different. What we call tactical queries. For example, we want to select one curve of one customer and compare it to the curve of its neighbors or to the curve of the people that have the same characteristics. And we also want to run aggregated analytical queries, like building aggregated curves on different criteria. These queries are predefined, but we also want to be able to run ad hoc queries and to extract data according to different criteria. I will explain Rocoflux, which is a business application just after. So our criteria are of two different types of criteria. We have quantitative criteria. We want to measure the performances, of course, of the queries. We define some level agreement for all of our queries. Some has to be done in less than 1 second, and the others, maybe 45 minutes is okay, or 1 hour. And we also measure how many queries run at the same time. So we wanted to have more than 1,000 queries at the same time, for example. And we also have a qualitative criteria in terms of the agility of the systems, for example, with the ad hoc queries, and the convergence between the operational use and the analytical use. We have run these POCs using very large databases, classical relational approaches with different partners. I won't talk about these POCs today, just to mention that we have run these POCs with these people, and we wanted to answer some of the questions that are there. And we decided to see if an Hadoop-based system could answer more or less the same criteria than these people. So I won't present Hadoop and all this ecosystem, you know it better than me, but we conducted this POC at the beginning of the year with our internal resources. Here I wanted to remind the data model I briefly described before. So you've got the customer information at the top. Then you've got some information about the network, about the geographical environment, the city, etc. The weather, because for all our applications, for lots of our applications, the weather information is important because it is very linked to the consumption. And finally, the measurements, the consumption with the table consumption, which is the most important because we store one measurement every 10 minutes for all of the customers. So remember, we had 100 terabytes of raw data, and with our implementation on Hadoop, we had 10 terabytes of data, and that we replicated 3 times. As I said before, we do not have all this data coming from the meters because they are not deployed yet. So we developed a data generator called, we called it Corbogen, and it allowed us to generate all this data, all these 100 terabytes of data. It's a customizable tool. You can define the interval. You can, if you want load curves with a measurement every 30 minutes, you can have, for example. If you want curves for only one city, you can have it also. We define the data quality. That means that we define if data are all synchronized or not, etc. In fact, to generate this data, we first took profiles that are public profiles in the French market. You've got a profile for customers with little equipment. You've got another profiles with customers that have lots of equipments, that have electrical heating, etc., etc. These profiles are public. And we add noise to this profile to generate all these curves because we wanted to have, of course, not all the same curves in order to avoid compression, easy compression. The Corbogen had to generate 100 terabytes quite quickly, so we implemented a distributed architecture. And you've got there an image of 35 million of curves for 1 week that was given with the help of someone in the room that knows. And to show you that we really generated these curves. So the design of a Hadoop system is quite classical. We use Hive for querying and managing the core of the system. And we also used HashBase, implementing the high concurrency and low latency queries. So Hive allows ad hoc queries and complex analytical queries. The customer tables are stored and replicated in the nodes of our system. We have 19 nodes in our system. I will give you some elements just after. And consumption measurements are partitioned by day and customer profile criteria. HashBase is used for low latency queries. There is a little mistake in the slide. I'm sorry. What is stored in in-memory tables are customer information because they're small tables. And the recent metering data are stored within HashBase, and we also store aggregates in tables. So here is the configuration of the system. And we used a Cloudera Hadoop distribution. So here you've got a snapshot. You see that we use a little more than 30 terabytes of data on our 19 nodes. So now I'd like to move the discussion on the time series format because it has an impact on the performances of the system. Usually Hadoop is used for non-structured data. All the things that we have read, or mainly the things we have read, don't consider very structured data like time series. So we had this question about how to model the data. So we had different choices. We can have a kind of tuple model. So in fact, it means that for each measurement, we create a line with the ID of the curve, the timestamp, and the measure. So we will have, for one day, 124 lines. We also can model in different types using an array to store within one array all the data for one day, or using a column approach. That means that we put 144 columns that represent the 144 times period times in the day. So here is an image of what I just said. Is you select an individual load curve, you can have this tuple representation with the 144 lines, or the array, or the column with 144 columns, only one line and a lot of columns. This has an impact on our results. For example, here, you've got a very simple query. You just compute a global aggregated load curve for one day, and you see that between tuple and the other representation modes, you've got quite a big difference of time, because it's the double between the 2 minutes and 1 minute. So we would like to have your feedback, if any, on these representations, and if you had other example of time series representation, it would be interesting for us. Now the results. Using HBase, tactical queries are really successful handled by HBase. We've got very low latencies and high concurrent load. It's a very acceptable results considering our business needs. For example, here, the query is just a selection of one curve, but we had more than 500 concurrent queries and a response time which is very low. So we were quite happy with these results. It doesn't work. For Hive, within Hive, we implemented analytical queries. So lots of our queries are computer aggregated curves. And you've got some examples here. And we wanted to show here the difference between the two first queries. The data was partitioned by time and by contractual information, and the two first queries use this criteria. So the execution time is quite good, and the two others are ad hoc queries that are not using this criteria. And so you see here, even if the queries are different than the first ones, we cannot really compare, but we see anyway a big difference between these two kind of queries. Recoflu is an internal business application, which is a very, very important application for EDF. Its objective is to compute different power consumption aggregations according to different criteria regularly. So there are a kind of updates of some information, and the criteria can change. Well, can change during the time. So temporal data is an important element. Finally, if you see that the six scenarios are to be run the one after the other, and finally to run all these scenarios, it takes 1 hour or a bit more than 1 hour, which is results are really acceptable for the business needs. At the moment, they use more time to do things with less data, for example. So we were quite happy with these results and show that Hadoop finally can find some use cases within our company. Here, I wanted to show you a France map to remind you how France is beautiful. So we realized this map using an integration with Tableau software. And so we visualized our generated data, and we visualized feeders, and they are well organized within the country. So our generation was quite good. There are some in Spain, but it doesn't matter. So as conclusions, we tried to distinguish between what seemed negative and what seemed positive after our Hadoop experience. Maybe we will update these things after the summit, because we learned a lot during the summit. But the image we had is that it was not so mature, and there were a few feedbacks in the industry. That's what we thought before coming here. And another important thing is that it seems to us that there are not so many competencies, so many skills, at least in France and maybe in Europe, on this technology. As for the editor's offering, we'll see that there are a lot of offerings actively emerging, and but maybe still young. But there are a lot of things positive to say after this experiment. The first thing is the cost, of course. It's a very low-cost solution. An important thing we talked before during the training or during other presentation is the ability to recycle existing commodity hardware. That's another important point, because in a company like EDF, we've got a lot of hardware, and we would like to use it different ways. Here we focused on the processing of time series and of this metering data, but we have also lots of different data in company, and we think that Hadoop is one of the few solutions that allows the coupling between structured and unstructured data, and it will become very important for all companies. And another point is the flexibility and the fault tolerant. Our system is, our internal cluster had lots of problems. We lost some disk, but we never lost data, and we could run all the queries we wanted to run. So finally, we showed it was really fault tolerant. It wasn't made on. As for perspectives, we go on working on this subject. Of course, we look at the different offering. What are the best hardware configuration for our company to use Hadoop solutions? We also want to use statistical libraries, because we don't only want to query our metering data, we also want to analyze it deeply with machine learning algorithm. And we have to have a big effort on thinking on the usages of such a solution within the company. we think it can have a role in the company. We have to go on thinking about it and find the right usage. We thought, for example, of using it as an ETL or as a solution for archiving data or publication for data as well. So I think I finished. Just well, we have showed a non-traditional usage of Hadoop using a structured schema and very structured data. We think it will become a company. We hope. We try to convince that it can be a component of our information system, and we would like to. We will be happy to have your feedback on our work and suggestions for the storage models or for the usages. Thank you.
Hi, I have a couple of questions. Yeah, I was wondering, first, the tool that you use, you call it Curvogen or Curvogen. Is that something you developed, or that was something that is available? The tool.
Yeah, we developed it.
And is it proprietary or is available?
Yes.
I see.
Yes.
Yes to the first proprietary, right?
Yes, it's our propriety. Yes.
And you also said that there were some. It was based on public profiles of electricity consumption.
I'm sorry, I didn't hear your question.
You said that it was based on public profiles of electricity consumption of some
yes,
users?
the profile. It's consumption profiles.
Right.
In France, with the opening of the market, the national regulatory publishes this profile. There are, I think, more or less 40 different profiles existing according to the customer's characteristic. So we use this profile because we didn't want to give well, these load curves, as you understood probably, contain lots of information, and it's a very important information for our company, and we don't want to give our own load curves. We have samples. We have some samples of load curves for all our customers, but this data generally we don't give this data to anybody.
And a couple of more quick questions. I was wondering, the electricity theft is one of the is it one of the use cases that you're considering or not? Are you analyzing data, or are you thinking of analyzing the smart grid data or smart meter data for identifying anomalies or possible electricity theft or non-technical losses?
I'm sorry, I didn't. There is an echo, and I don't hear your question.
Sorry, maybe I should step backwards. I was wondering if one of the use cases that you're thinking of for like doing analytics on smart grid data is one of them electricity theft or non-technical losses?
I didn't understand your question. I'm sorry.
Well, it's okay. I'll talk to you after.
On analytics, is it on analytics? You mean?
On electricity theft, I was wondering if it was one of the use cases.
We are from EDF, so we use only data coming from our company. It's our use case. J'entends rien. Je suis désolée.
Bon, aux États-Unis, il y a des gens qui peuvent voler électricité. Alors, ils demandaient donc la question que est-ce que votre système peut faire détection de quelque chose comme ça, des gens qui volent l'électricité?
Ah, de la fraude.
Ouais.
We didn't focus on analytics, but of course we work on fraud detection, and in other projects, but we could implement such algorithms. In fact, in our project, we look at which algorithm we could implement on Hadoop with different libraries like Madlib or Mahout or other things. And fraud detection, we have some algorithms and that are used, and yes, probably this data could help on detecting fraud detections.
Okay, I have several questions. The first one is, you're measuring all the meters once every 10 minutes. Is that just for the POC, or is that the production setup that's going to be deployed on the 35 million meters?
No, it's the interval of time is not completely, as far as I know, completely defined, but it will be for all customers. Yes, there are probably, we think that it will be for all customers, this 10 minutes interval, but it's not completely decided yet.
Okay, and my other question is, does EDF actually intend to hold a challenge where they would provide sample data and actually let global team compete on performance or request, queries that can be run on that data?
I cannot answer for
Well,
the
you should
EDF
definitely
strategy.
think about it.
I'm sorry. Maybe, but I cannot answer this question.
Okay, and my last question, did you consider Pig instead of Hive for querying the data?
Sorry, did you consider?
Did you consider Pig instead of Hive?
We try to use Pig, but at the end we focus on Hive. It is what we show you here.
Well, was there a reason for that? Did you hit a wall with Pig, or?
Because we have a well knowledge in SQL. This was one of the main reasons.
Okay.
And also that we know the background of our IT professional, and as they know very well SQL, we think that this is a good point to try something that will, if we have a deployment of Hadoop in production, we need to have a small gap between what we do today and what we will do tomorrow.
Okay,
this
so
is what we focus on now.
So I definitely think you should hold that challenge.
Merci beaucoup. Très bien. When you made the decision to go from 6 measurements per year per customer to every 10 minutes, can you speak about that decision? Because it's so many orders of magnitude difference. Why such a dramatic shift?
Well, in France there is a law that decided to install these meters. And this deployment is ordered by the government and by the CRE, Commission de Régulation de l'Énergie, which is a regulatory institution. And for the interval time, first we talked about half an hour data. And now we talk more of 10 minutes data. Well, these decisions.
Is it arbitrary, or is there some need? Because you obviously didn't need it before.
We've got different samples of data in EDF because we install some devices into different households, and we take the data, and lots of our analysis are made upon 10 minutes data, 10 minutes interval data.
Thank you.
So that's even for forecasting or for. It's important. Another question? No? Finished? Time to the cocktail. Okay.